Okay, welcome back. We are going to continue Chapter 7, continue our factoring of polynomials. And let's just review what we've done so far. I've listed out here the steps for us. Whenever you are factoring any polynomials, it is strongly recommended that you go through these steps one at a time to make sure that you have your fully factored form of a polynomial. And of course, step one, you want to make sure your polynomial is in descending order of powers. Step two, you want to make sure that that leading coefficient, okay, is in fact a positive number. That could influence now step three, where you look to initially factor any greatest common factors. And the other day we spent a great deal of time because there were many different types of greatest common factors. We talked initially about looking for a common constant, a common number that can be divided into all of the terms. We then talked about a variable that can be common. Remember, when we were talking about a variable, you're always looking to utilize the smallest power. If we have a product of constants and variables, then we call that a common monomial. And then lastly, we also talked about the fact that you can have a common polynomial, all right, as your four different types of greatest common factors. Then we finished off section 7.1, where we talked about after you have successfully done steps 1, 2, and 3, if you see that your polynomial is made up of four terms, that's when you look to factor by grouping, okay, where you group the first two terms, you look to see what their greatest common factor is, and then you look at the next two terms and you factor out their greatest common factor, and then you'll notice you found a common polynomial that you could take out as well. Okay, so that one was a little bit different. Now, in our new section, section 7.2, we're going to add another step in that we're going to be focusing on, in section 7.2, factoring two types of trinomials. Now, trinomials are three-term polynomials. And like I said, we're going to break it up into two different types. The first type looks something like this: x squared plus bx plus c, where there is a coefficient of the x squared term, and that coefficient will, in this particular case, will always be the number 1. And then you're going to follow it up with a bx, which of course is your linear term, and that will have a coefficient, as well as your final term, the term c, that will be just a constant. So let's take a look at some examples. Let's say we have x squared plus 5x plus 6. Remember, it's important that we go through steps 1, 2, and 3 initially, all right? So in step 1, it is in descending order of powers. Step 2, our leading coefficient is a positive number. It's a positive 1. And step 3, there is no greatest common factor, okay, between those three terms. We don't have to worry about step 4 because it is not a four-term polynomial, but it is a trinomial. And let's take a look at how we're going to factor down these trinomials. What I'm going to recommend that we do is that we're going to set up two parentheses, okay? And then we're going to ask ourselves, what would we have to multiply? Because remember, factoring is the opposite of multiplication. It's the opposite of that FOIL, all right? So what would I have to multiply here and here by to get x squared? And of course, that would be an x. So we're going to have to place an x here and an x here in those first slots of the parentheses. Next, what we want to take a look at is the last number now, c, okay? We need the factors of c. What two numbers, when we talk about factors of a number, we're talking about what two numbers multiply to form that number. So we need factors of 6. Factors of 6 would be either 1 and 6, because 1 times 6 is 6, as well as 2 times 3, that would be another pair of factors. We could go with, of course, a negative 1 times a negative 6. That would give us a positive 6, as well as a negative 2 times a negative 3. What I have listed out here are all of the factors of a positive 6. Remember, we need two numbers that multiply to that last number 6. But now I have 4 different sets of numbers to choose from. Which set do we go with? Well, we need the set of numbers that add up to the middle number, in this particular case, the plus 5. So let's see if we were to add these factors together, we would get 7, 5, negative 7, and negative 5. And since we need to add up to the middle number, we can go with the set of factors of 2 and 3, because when we add them together, they give us the 5. So we would need to put a plus 2 and a plus 3. Now I know what you might be thinking. Does the order that I put the numbers matter? And of course the answer is no. I could have also written x plus 3 and x plus 2, and that would also be correct, okay? Because with multiplication, order does not matter, and whether we multiply the first two together or if we multiply the second two together, we will in fact get the same original polynomial. And at the beginning, as you are learning how to do this factoring, you might want to check your answer by performing that multiplication just to play it safe, okay? As I said the other day, factoring is one of those skills, okay, that we're learning here in Chapter 7 that is essential for all other math courses that you might be taking later on, okay, whether it be pre-calculus, calculus. You will use factoring a great deal in those courses. So it's important that you get down these foundation steps that I'm providing for you, okay? Let's take a look at another one. Let's say we have, we'll do something similar. X squared minus 5x plus 6, okay? It is very similar to the one that we just did, and so step 1 is done. It is in descending order. My leading coefficient is positive. Once again, there is no greatest common factor, and it's not a 4-term polynomial. So we're already up to step 5, where it is a trinomial that we will try to factor. And once again, we'll set up our parentheses. Once again, what would I have to multiply to form an x squared? But of course, we're going to put an x and an x. Now, I've already listed above, and I left them there for us to take a look at. I need, once again, the same factors of 6, but now they have to add up to a negative 5. And so what we have here, we need to go with a negative 3 and a negative 2. Okay? Once again, the order I can change. I could have put an x minus 2 and then follow that with an x minus 3, and that would perfectly be fine as well. You can give me either form of the correct answer. Okay? Before we go any further, I want to just take a look at the signs, okay? Because certain signs will tell us what the signs have to be on the inside. Let's just take a look at the answers for a moment. What do we notice here in terms of the signs? Well, here we have a plus and a plus. In the second example, we have a minus and a minus. We have the same signs, both positive or both negatives. And I knew that just by looking at the problem, because what you want to take a look at is that last sign, that plus 6. And the fact that it's a plus 6, that's going to tell me that we are in fact going to have the same signs inside the polynomials, okay? Now, how do I know it's going to be a plus sign or a minus sign? Well, for that, you have to look here, or you have to look here. You have to look at the sign in front of the b term. Once you determine that you are going to have the same sign, you look in front of that b, that linear term, and that will tell me what kind of sign I'm going to use, okay? Let's do another example. Let's say we have x squared minus 7x plus 12. Okay. The more information that you can tell just by looking at the problem, the easier these will become for you. If you are good with your mental multiplication and addition skills, factoring will also be easier for you. As you begin factoring, it might seem very tedious and very time-consuming, but be patient. It'll come. And like I said, factoring is one of those skills that we will use extensively in Chapter 7, as well as in our next chapter, Chapter 8. Okay, so you want to make sure you get down the ideas of factoring. So, first of all, once again, step 1, descending order, leading coefficient is positive, as well as there is no greatest common factor. It's a trinomial. Okay, it's the kind that we've been dealing with here, where we have a leading coefficient of just the number 1. Believe it or not, these are the easier kinds. So now let's take a look. Factors of x squared have to be x and x. Now, what do I know about my signs? Well, remember, if I can tell something about my signs, the fact that it is a plus 12, that means, I set it up here, it's going to be the same signs inside the parentheses. What kind of sign do I have to use? Well, that's what I look at the sign in front of the b term, the linear term. So they're going to be the same sign, and I need two negative numbers. So I need a negative here and a negative here. Now, this is where your mental math skills come into, to help you. I need two negative numbers that multiply to 12 and add up to that negative 7. Okay, because that's what you want to keep in mind. The two numbers must multiply to that positive 12. So I need two negative numbers that multiply to 12 and add up to a negative 7. And if you think about it, okay, and if you go through your multiplication tables that multiply to 12, we can only go with two numbers of 4 and 3. So I could put them in any order. I'm going to put the 4 first and then follow it up with the 3 second. And that would be your answer. X minus 4 times x minus 3 would be the product. If we were to multiply them together, it would bring us back to the original polynomial. Okay, and that's why I could throw an equal sign in between, because they are, in fact, equivalent to one another. Let's try to give you one, okay? I'm going to give you one to try on your own. I'm going to write down the problem and then pause the video and see how you make out. I would like you to factor. Let's say we have x squared. Maybe I'll do plus 9x plus 20. Okay, take a moment now, pause the video, try this problem on your own. When you think you have an answer, turn the video back on and let's see how you made out. Well, if we set up our parentheses, okay, factors of x squared, once again, that's going to be simply an x and an x. Let's plug in what we know about the signs. The fact that we have a plus 20, once again, that means we are going to have the same sign. What kind of sign do I need to put in? Well, that's when I look in front of the linear term. I need to have two positive numbers. So let's put them in. So now I need two positive numbers that obviously multiply to 20, but add up to the number 9. And if it's helpful at the beginning, it might be in your best interest to actually list them out. So if you want to list out the factors of 20, that of course would be 1 and 20, 2 and 10, 4 and 5. Those are the pairs of numbers that multiply to 20. But now, more importantly, we need to take a look at those pairs and see which add up to the middle term, the linear term, in this particular case, the 9. And I think it's safe to say that if we take that last pair of 4 and 5, we'll be able to come up with the answer. So we'll have x plus 5 as well as x plus 4. And that would be the factored form of your polynomial. Okay? Once again, if you changed up the order and wrote x plus 4, and then you wrote x plus 5, that's perfectly fine. I would also mark that correct, okay? Because once again, with multiplication, order does not matter, okay? I want to take a look at something different now. Same type of idea, same involving trinomials. For example, let's say we have the following. X squared minus 8x minus 20 now. Okay. Once again, we'll set up the parentheses, x and x. Those go in the first slots because it's x times x that multiply to x squared. But in all the problems that we've done so far, we were adding that last constant, okay? In the problem just above, we added the 20. In the problem before that, we were adding the 12. In the first and in the second problem that we first began doing, we were adding the 6. And in all those cases, in those 4 examples that we did, I had indicated that because you are adding that last number, that you're going to have the same signs inside the parenthesis. But now we see here that we are subtracting that 20. And when you subtract that last number, that means you are going to have, in fact, inside the parentheses, different signs. One will be positive and the other will be negative. Because if you think about it, the only way to get a negative product is if the numbers are different signs. One has to be positive and one has to be negative, because we know that a positive times a negative will ultimately give you a negative number. And so now, once again, we need to come up with, all right, one positive and one negative number that multiply to the negative 20, but remember now they have to add up to the negative 8. So let's think about it. Let's once again list out what numbers multiply to a negative 20. I, of course, can use negative 1 and 20. I could do negative 2 and 10. I could do negative 4 and 5. But don't forget, I can also change which number is negative, in that I could do a positive 1 and a negative 20. I could do a 2 and negative 10, as well as I could do a positive 4 and a negative 5. So now I actually have 6 pairs of numbers that multiply to the negative 20. Which pair do we use? Well, remember, they have to add up to the negative 8, that linear term. So let's just think about these numbers for a minute, and let's see which pair adds up to a negative 8. Well, the first pair, 19, then we get 8, then we get the number 1, negative 19, negative 8, and negative 1. Did we find a pair of numbers that add up to the middle term? Sure we did. In which case now we have to put a positive 2 first, and the 10 is negative, that has to go second. Okay? The 10 has to be with the negative number, the negative sign, and the 2 must be with the plus sign, because the 2 has to be positive and the 10 must be negative in order for us to get that negative 8. Once again, if you want to change the order, in which case you would put x minus 10 and x plus 2, that's perfectly fine. As long as the 10 is negative and the 2 is positive, the order does not matter. Let's have you try another one. Once again, let's have you try this one on your own. Let's say we had the following. X squared plus 2x minus 48. Okay, once again, we want to go through our steps to factoring, and we want to factor this polynomial completely. So pause the video and give it a try. It's okay if you make a mistake. Let's see what happens when you return. Well, if I set up my parentheses, what multiplies to form, once again, the x squared would just be an x and an x. What do we know about the signs? Are they going to be the same or are they going to be different? Remember, look at that last sign there. And if it's a plus sign, that means it's going to be the same signs. And if it's a minus sign, that means we're going to have different signs. Those are the things that you want to take a look at. Well, the fact that it's a minus 48, I know I need different signs. One will be plus, the other minus. And now I need to come up with two numbers that multiply to a negative 48 and have to add up to a positive 2. Well, there's lots of numbers that multiply to 48. Think about your different pairs, okay? The one pair that comes to mind that would work in this particular case would be a negative 6 as well as a positive 8, okay? Because negative 6 times 8 does equal a negative 48, and negative 6 plus 8 adds up to the positive 2. So let me put my numbers into my parentheses. So we're going to have to do x plus 8 as well as x minus 6. That would be your solution, your factored polynomial. Okay? Hopefully you did okay with that one. I want to see what we could do here. Similar example, x squared plus 4x plus 6. Now let's think about this one. If we were to set up our parentheses, x and x, that much we know is true. What else do we know is true? Let's take a look at the signs. Since it's a plus 6, we know we need the same sign. What signs are we going to use? We look in front of the linear term, so we need the same sign, both positive signs. Okay, now let's think about the number 6, the factors of 6. Well, once again, they have to be two positive numbers, so I only have two sets. I can either go with 1 and 6 or 2 and 3. But remember, they have to add up to 4 in the middle. Well, if 1 and 6 is 7, 2 plus 3 is 5, neither one of these pairs add up to the middle term. Now, this, you didn't do anything wrong, okay? What we have here is a special case. What we have is a very special type of polynomial. It is similar, we're going to use a word similar that you would use when you describe numbers like 2, 3, 5, 7, 11, the number 13, the number 17, okay? Think about those numbers once again. And there was a word that you used probably way back in elementary school that you learned to describe those particular numbers. Once again, numbers like 2, 3, 5, 7, 11, 13, 17. Back in the day, you described those numbers as being prime numbers, okay, because they were only divisible by 1 and itself. And we're going to use that word once again. The x squared plus 4x plus 6 is going to be considered a prime polynomial because it is not factorable by any means that we know of other than 1 and itself, okay? So if ever you encounter a polynomial that is not factorable by any other means that we talked about in those earlier steps, that's when you say that you have a prime polynomial, okay? So not all polynomials are factorable. There are special ones that are in fact prime. Let's take a look at another one. The more that we do, the better practice that you, the more practice that you do, the more comfortable you will feel with these problems. Let's say we have 2x plus x squared minus 15. Now, don't forget, we have to go through our steps. And the very first step, we want to put this polynomial in descending order because it is not. And so we're going to rearrange the terms. I'm going to put x squared, then a plus 2x minus 15. So step 1 is done. Step 2, my leading coefficient's already positive, so I don't have to worry about step 2. There is no greatest common factor, so I'm going to skip right over step 3. And since it's not a 4-term polynomial, I'm going to move right along to step 5, the new step. So let's set up the parentheses. Let's plug in our x values. We know we have to put an x and an x. What do we know about the signs? Once again, we look at the last term. The fact that it's a minus 15, we know that's going to be different signs, one positive and one negative. And so now we need factors, two numbers that multiply to a negative 15 that would also add up to a positive 2. Well, we can only go with a positive 5 and a negative 3. Those would be the only two numbers that would work. Factoring is like a puzzle, and you have to put the pieces in their correct spot. Okay, so our factored form would be x plus 5 over times, I should say, x minus 3. That would be the factored form of the original polynomial. Okay, very important that you go through the steps. For example, let's say we had a 6x squared plus 18x plus 12. We're going to get them a little bit harder each time. Once again, step 1 is done because the polynomial is already in descending order. Step 2 is also done because our leading coefficient is a positive, in this particular case, a positive 6. However, there is step 3 that we have to perform here. Looking carefully at these 3 terms, I recognize that all 3 terms are divisible by a greatest common factor, and in this particular case, the greatest common factor happens to be the constant 6. So remember, when we have a greatest common factor, what do we have to do? We take the greatest common factor and we kick it outside a pair of parentheses. And then we would have to divide all 3 terms by that greatest common factor. In which case now, 6 divided by 6 would leave us with a 1x squared. 18 divided by the 6 would leave us with a plus 3x. And then lastly here, the 12 divided by 6 would leave us with a positive 2. But now we want to factor completely, so we want to factor this further. So what do we have to do now? Well, the 6 comes along for the ride. Don't drop the 6, that's outside. I'm then going to proceed to set up my parentheses, and I'm going to factor the trinomial like we did in the previous examples. Factors of x squared, x and x. What do we know about the signs that we're going to have to put inside the parentheses? Well, the fact that it's a plus 2, that means it's going to be the same sign. What sign do we have to use? Well, that's when I look in front of the linear term, and so it's going to be the same sign. I need 2 positive numbers. So let's throw that in. Finally now, we need 2 numbers that multiply to 2 and add up to 3. So let's go with the only 2 numbers that we have, 2 and 1. So the fully factored form of that polynomial is the number 6 times x plus 2 times x plus 1. And you must have all 3 parts, okay? Because if you don't have, let's say, the 6, okay, if you dropped the 6, if you forgot to write the 6, they would not be equivalent. Okay, and they are in fact equivalent to one another, and that's why I'm able to put this equal sign here. They mean the same polynomial, they're just in a different form. One is written as a polynomial, the other is written as a product of polynomials. Okay, so it's very important that you go through your steps. Now, I did mention that there are two types of trinomials that we're going to take a look at. These easy kinds, okay? And these have been the easy kinds. I know what you're thinking, that maybe they weren't so easy for you, but that will come with practice. And why do I call them the easy kind? Well, because the leading coefficient was always a 1, okay? But what happens, the second kind of trinomial that we're going to have to take a look at? We're going to take a look now at factoring a trinomial where your leading coefficient is not the number 1. It's going to look something like this. ax squared plus bx plus c. So the only difference is that you will have a different leading coefficient. It won't be the number 1, okay? It could be any number that would work. For example, let's say we have the following. 2x squared minus 7x plus 3. Now, step 1 is done in the sense that our polynomial is in descending order. Step 2, the leading coefficient is positive. Step 3, there's nothing common to factor out. Very important that you go through those 3 steps. Don't forget about those. It's not a 4-term, so we're not going to worry about grouping. It's a trinomial. And it's a trinomial, it's not the easy kind, all right? Because our leading coefficient happens to be a positive 2. Now, what I'm going to show you is how we're going to be able to factor this down. There's a couple of different methods that you may have learned. Some use a guess and test method. Some use what's known as the AC method, okay? Other people use what's known as a borrow and give back method. And that's the one that I'm going to show you. Students tend to like the borrow and give back method. So, what I want to do is I'm going to trick this trinomial. I'm going to turn it into an easier kind of trinomial. And the way I'm going to do that is I need to multiply, okay, this last number 3 by the number 2, the leading coefficient. And so now this is going to become simply x squared minus 7x plus, now when I multiply the 2 with the 3, we get 6. So I am borrowing that 2, and I'm going to multiply it with the 3. And I have now created a much easier trinomial to factor, because it becomes 1 like we were doing previously, where your leading coefficient is 1. And now I'm going to factor this down. So I'm going to set up my parentheses. Notice I'm using a different color here, okay? Because I'm factoring down now the red trinomial, even though the black trinomial is the original one that we ultimately need to factor down. So I am borrowing that 2, and I'm going to factor down now the red trinomial. X and X. What do I know about my signs? They have to be the same sign. They have to be 2 negative numbers. Negative and negative. And now I need the factors of 6 that add up to 7. Well, I'm comfortable with my multiplication and addition skills, so I know I have to put a 6 and a 1, because 6 times 1 is 6, and the 6 and 1 add up to 7. So that's the borrowing part. But we're not done, because what I have here in red is the factored form of the red polynomial. I have to now give it back. I have to give back that multiplying by 2. So what I'm going to do now is I have to do the opposite of multiplication, in that I now have to divide those 2 numbers, the 6 and the 1, by the 2. That's the part where we're giving it back now. Let's simplify what we can here. So we have x minus 6 over 2. Well, 6 over 2 would give us now x minus 3. Now we have this x minus 1/2. I can't simplify the fraction 1/2, and we don't want to leave our answer with a fraction. So here's what I'm going to suggest that you do. You take that denominator of 2 and you're going to move it up next to the variable x. And so you would get a 2x minus 1. And that would be your factored form of that polynomial. If I was to multiply this back, we would get the original black polynomial. Okay, notice the difference in colors. When I borrowed, I multiplied by that leading coefficient of 2, okay, and that created an easier trinomial to factor. Once you factor the easier trinomial, I have to give it back, okay? I have to give back the multiplication of 2. And the way to give back the multiplication of 2 is to divide by the 2. And I have to divide both numbers. You simplify what you can. 6 over 2 simplifies to 3. Since 1 over 2, 1/2 can't simplify, all you look to do is to eliminate the denominator by taking the denominator of 2 and moving it up next to the x. And that gives you your factored form. Let's try a few others. Let's say we have 3x squared minus 10x minus 8. Step 1, it's in descending order. Step 2, the leading coefficient is positive. There isn't anything common to factor out of the 3 terms, so that takes care of step 3. It's not a 4 term, so we're not even going to worry about step 4. Trinomials now, step 5, and it is the more difficult kind because your leading coefficient happens to be the number 3. So once again, we're going to trick this problem into thinking it's an easier trinomial, in that I'm going to borrow that 3 and I have to multiply it with the 8, okay? And that's going to give me x squared minus 10x, and when you multiply the 3 with the negative 8, you in fact get a negative 24. So we have now created a trinomial that's going to be much easier for us to factor. Let's set up the parentheses. The factors of x squared, x and x. What do we know about the signs? Well, we know the signs have to be different, okay, because of the negative 24. So I'm going to put the plus sign and then the minus sign. And now we need factors of a negative 24 that add up to a negative 10. Well, there are a lot of factors of 24, okay, think about that. And which pair would add up to a negative 10? Well, if I have a positive 2 and a negative 12, that will work, okay? But now remember, that's not the answer because it's in red. We have to now give back the multiplication because we want to factor the original black polynomial. And to give back, I will now have to divide both numbers by the 3. Let's simplify what we can. Well, 2/3 can't be simplified. So we just have to get rid of that fraction. So I'm going to move the 3 up next to the x, and we get a 3x plus 2. In the second parentheses, I have 12 over 3. That can be simplified into an x minus 4. And that would be your factored form. If we were to multiply those back, we would get the original polynomial. That's what we're looking to do. Let me give you one to try on your own, okay? I'm going to give you a problem. Once again, pause the video and let's see how you make out. And when you're done, turn the video back on and let's check your answers. So here we're going to have the polynomial of 10x squared plus 37x plus 7. Okay? Turn the video off for the moment, work through the problem, and see how you do. When you're done, turn the video back on and we'll work through it together. Well, once again, steps 1 through 4 we don't have to worry about here. Okay? So, in step 5, it's a more difficult trinomial. So what I'm going to do is borrow that 10 and multiply it with the 7, giving me an x squared plus 37x plus 70. Once again, we magically turned the more difficult trinomial into an easier kind, and we're going to factor down this easier trinomial. So I set up my parentheses. Factors of x squared have to be x and x. What do we know about the signs? Well, they have to be the same sign. We need two positive numbers. Factors of 70. What two numbers multiply to 70 but also add up to 37? Well, that happens to be the numbers 2 and 35. 2 times 35 does equal 70. 2 plus 35 does equal 37. But remember now, we're not done with the problem just yet. It's still in red. I have to be able to have the factored form of the black polynomial. So I'm going to give back. I'm going to give back the multiplication of 10 by dividing both numbers by 10. And then we'll once again look to simplify. X plus, well, 2/10. 2/10 can simplify into an equivalent fraction of 1/5. When we have the x plus 35/10, once again, 35/10 can also be written as the simplified fraction of 7/2. But we do not leave our answer like this. We have to get rid of all fractions. And how are we going to do that? I'm going to take the denominator 5 and move it next to the variable x. So that would give us a 5x plus 1. I have to do the same thing with the number 2. I have to get rid of that denominator, in which case I will have a 2x plus 7. And that is the factored form of the original polynomial. Okay, if you don't believe me, you can always FOIL it back, okay? But that is your factored form of the original polynomial. Very important factoring. You want to practice your factoring because it is that essential skill that we will use a great deal in both chapters 7 and 8, as well as in your future math courses, okay? So for practice purposes, take a look at the homework and go and try those problems dealing with section 7.2, the factoring of trinomials. When you factor the trinomials, you want to make sure that you go through all of the steps. Once again, descending order, leading coefficient should be positive. If there is a greatest common factor, factor it out first, okay? Then once you factor out the greatest common factor, look to see if it's a 4-term. If it's 4-term, you factor by grouping. If it's a trinomial, if it's a 3-term polynomial, you look to see if it's the easy kind or the more difficult kind, okay? And you want to handle them appropriately. So try those homework problems. Shoot me any emails that you have questions about or any concerns that you may have. In our next section that we will take a look at in our next lesson, we're going to talk about special binomials, and that will be the last type of factoring that we will do, okay, the special binomials in section 7.3. Until the next time, be well.